that is also called differential equation with variable coefficients. So this is mainly of two types. First type is Cauchy's homogeneous linear equation, which is of the form x to the power n dny dx to the power n plus a1 x to the power n minus 1 d to the power n minus 1 y dx to the power n minus 1 plus dot dot a n y, which is equal to fx, where these coefficients a1 a2 an, these all are constants. तो इस टाइप के इक्वेशन को हम कैसे सॉल्व कर सकते हैं? सो दिस इज द मेथड हाउ टू सॉल्व दिस टाइप ऑफ इक्वेशन. सो हियर वी टेक x as e to the power z. In place of x we will take e to the power z, which implies z is equal to log e to the power x. dy upon dx is equal to dy upon dz into dz upon dx, where dy upon dz is 1 upon x into dy upon dz. So here, from here we can find dz upon dx, which is equal to 1 upon x. So this is further x dy upon dx is equal to dy upon dz, which implies x dy upon dx is equal to capital dy, where we supposed यहाँ पे हमने capital D को d upon dz लिया है. तो हम देख रहे हैं कि अगर x dy upon dx है तो उसे हम लिख सकते हैं capital dy. Similarly for x square d square y upon dx square को हम लिख सकते हैं d into d minus 1 into y, जहाँ पे capital D है small d upon dz. Then for x cube d cube y upon dx cube को हम लिख सकते हैं d into d minus 1 d minus 2 into y and so on, जहाँ पे understood है d क्या है small d upon dz. तो इसे हम एक एग्जाम्पल से समझ सकते हैं. So x square d square y upon dx. So we have taken example. Solve x square d square y upon dx square plus x dy upon dx minus lambda square y is equal to 0. So यहाँ हमारे पास x is equal to e to the power z, as the method is यहाँ पे हमें सबसे पहले x is equal to e to the power z suppose करना है, which implies z is equal to log e to the power x, and x dy upon dx is capital dy, and x square d square. So that implies after putting all this substitution we have d into d minus 1 y plus dy minus lambda square is equal to 0, which implies d square minus d plus d minus lambda square y is equal to 0. So finally we have d square minus lambda square y is equal to 0. So in this way auxiliary equation of this differential equation is m square is equal to lambda square, where m have plus minus lambda as roots. So m have two roots, plus lambda and minus lambda. So complementary function is c1 e to the power lambda z plus c2 e to the power minus lambda z. Then complete solution is equal to cf, as r is equal to 0, so there is not particular integral. So y is equal to c1 x to the power lambda plus c2 x to the power minus lambda. Second form is Lysander homogeneous differential equation. तो ऐसा differential equation जो इस form में हो ax plus b to the power n dny upon dx to the power n plus a1 ax plus b to the power n minus 1 dn minus 1 y upon dx n minus 1 plus dot dot a n y is equal to fx, where these a1 a2 an are constant. So this type of equation is called Lysander's homogeneous differential equations. So method of solution is, यहाँ पे हम ax plus b को e to the power z सपोज करते हैं, सब्सटीट्यूट करते हैं, और फिर which implies z is equal to log ax plus b, then dz upon dx is equal to a upon ax plus b, and dy upon dx we can write dy upon dz dot dz upon dx. यहाँ पे हम dz upon dx की वैल्यू रख देते हैं, which is a upon ax plus b into dy upon dz. now अब ये x plus b अगर आप लेफ्ट साइड ले आओ तो दिस इज ax plus b into dy upon dx is equal to small a and here we have written small d upon dz as capital D into y. Similarly for ax plus b whole square, d square y upon dx square is equal to a square capital D into d minus 1 y, and so on. So we have taken example, solve x plus 1 whole square d square y upon dx square plus x plus 1 dy upon dx plus y is equal to 2 sin log x plus 1. So for solution, here we will compare it with ax plus b which is legendary linear differential equation, जहाँ पे ये कोफिशिएंट ax plus b होता है. तो अगर हम ax plus b is equal to x plus 1 रखें और दोनों साइड कंपैरिजन करें तो a की वैल्यू 1 होती है और b is also 1. Now taking x plus 1 is equal to e to the power z, we have z is equal to log e to the power x plus 1. Now जैसा कि मेथड ऑफ सोल्यूशन कहता है कि x प्लस 1 dy अपॉन dx हम ले सकते हैं कैपिटल dy. सिमिलरली x प्लस 1 स्क्वायर डी स्क्वायर वाई अपॉन dx स्क्वायर को हम लिख सकते हैं a स्क्वायर इंटू डी डी माइनस 1, जहाँ पे a क्या है 1 है. सो दिस इज इक्वल टू d इंटू डी माइनस 1 इंटू वाई. नाउ वी विल यूज दिस ऑल वैल्यूज इन इक्वेशन फर्स्ट. अब ये सभी वैल्यू हम यहाँ पे इक्वेशन फर्स्ट में रखेंगे. Using these values in equation first, we have d into d minus 1 plus d plus 1 y. So after putting these all in equation first and obtaining complementary function, we have c1 cos log e x plus 1 plus c2 sin log e x plus 1. After that we calculate particular integral. Particular integral is equal to 2 sin z upon d square plus 1. 2 sin z how? यहाँ पे log x प्लस 1 है, log x प्लस 1 इज इक्वल टू z है, तो हम यहाँ पे अगर इसकी वैल्यू z रखते हैं तो दिस इज 2 sin z. सो पार्टिकुलर इंटीग्रल वी हैव 2 sin z अपॉन डी स्क्वायर प्लस 1. 2 sin z अपॉन डी स्क्वायर है. अगर हम z का कोफिशिएंट 1 यहाँ पे रखें विथ नेगेटिव साइन तो ये 0 हो जाता है, एफ डी की वैल्यू 0 हो जाती है, इसलिए हम इसे डिफ्रेंशिएट करेंगे. डी स्क्वायर का डिफ्रेंशिएशन 2d and 1z on numerator. So now we have z sin z upon d. So z and then 1 upon d means integration of this sin z. So z upon d and integration of sin z is minus cos z. Therefore z is minus log e x plus 1. This is already given here.